Now we have two vectors that are not acting on right angles. So we have to evolve from Pythagorean theorem and SOHCAHTOA into using the sine law and the cosine law. Sine law will be used to find the second angle, while cosine law will be used to determine the magnitude of the vector. We still do need a sketch. We have a force of 70 newtons due west, and a force of 50 newtons in a direction of west 50 degrees north, which would be approximately this direction. We have the dotted line, so we can measure 50 degrees from the west, and our resultant vector is here. I should put the magnitude of this vector in 2. $50 newtons on that angled vector. First things first, we do need to find the magnitude of that vector. We need to find the length of the side. To do that, we use law of cosines. In order to use the law of cosines, however, we do need an angle within the triangle. The only angle we can deal with in the triangle is that one in red. It's the only place we know any information. That's the 50 degrees north of west from the second vector. What we can tell out of that, because we have the straight line, is that that angle in there needs to be 130 degrees. So when we go to use the law of cosines, we'll always be finding small c. That'll always be the resultant vector. The angle big C will always be the angle that's across from the vector. So now all we have to do is fill in and if you're wondering, A and B don't matter, they can be switched and flip-flopped. 70 squared is 4,900. 50 squared is 2,500. The last piece we can do all in one step. So 2 times 70 times 50 times cosine of 130, which is negative 4,499. But since we have the minus from the equation, the minus from the calculation ends up being plus 4,499. Add those all together, 11,899. Take the square root of both. And to correct sig figs, calculator will tell you 109. We need 2 sig figs, so 110 newtons. The angle, well, is the angle from the first vector up to the resultant. They're in blue. That angle is generally west and some angle north. To find the angle, this is where we use law of sines. Here, we'll use the magnitude that we just found. I'm going to call that little a, over sine of the angle opposite to it. The angle opposite to that is 130 degrees. In choosing little b and big B has to be the angle that we need to find. Little b is the magnitude of the vector opposite that, the side of the triangle opposite that angle. In this case, that's 50. Do a little bit of math. Take your calculator, calculate sine of 130 degrees. When you're dealing with trig and finding the decimals, 5 decimal places is enough. Cross multiply here, 110 times sine b, 0.76604 times 50. We get 110 sine b equals 38.302. Divide both sides by 110. We've got sine b equals 0.34820. Take sine to the other side to get angle B. And we get 20 degrees. 2 sig figs, so line over the 0. So our angle is west 20 degrees north.